Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome back in lecture 5. Student, basically in this lecture we will talk about and solve a question, okay, that is basically related with the effect of bracing, okay. So this is question number 4, and here you understand what is the effect of lateral bracing. So to start this question, let us watch this video. I already played this video in So we have one case in which it says that when your LV is LV, it means that if the beam is laterally braced at ends only, determine the flexure capacity if the beam length is 8 feet, 12 feet, 24 feet, 32 feet. This means that we have only any lateral bracing, one is here, you see. One lateral bracing is here, okay, and one lateral bracing at the side, okay. Now, they basically change this same length, clear? They basically what they do, they basically change this length, clear? In case A, they basically set this length same that is LV, and it basically LV is nothing you can. LV is basically your this LV in the first case is equal to F. Clear? Now in the second case, your LV is changed to I think to 12 feet. In the third case, it is changed to the same length is basically increasing. So they basically show you the effect of increasing this LV. Okay, they reaches it to the 32 feet, and then they ask to compute the end value. Now you see, in this case you got the maximum one, and in this case you got the minimum one. So here you will have the minimum one, and here you have the maximum one. Clear? Why? Because here we have the minimum LV, and here we have the maximum LV. If you come here and you see the values basically as feet, then it's going up 24 and 32. So it's 32 you have the minimum value, and it's 8 feet you have the maximum value. So let us start with the question and do this. One important thing I want to share with you that as you see some pictures of gantry crane, basically it is a crane which is working in marble factory, basically at the locations of harbors. Okay, so in this picture you see basically there is only bracing which is provided to the end. Okay, you see the bracing is only provided to the end. If you go to the marble factory, you see this kind of cranks. Okay, so there is no bracing in interior section. So what is the effect of this kind of basically here your LV is fixed, while there you increase, let's say, bracing to this, it will increase the capacity of this beam. But here as the crane moves, so for that purpose, to do that, it cannot provide because the wedge is hanging over here and there is a wire basically is connected with the crane. So it freely moves in between these two supports. So that's why we are bound to provide only bracing to here and to here. Now I have other picture as well. Let me show you. The other picture is this one. This is also a gantry crane, and okay, this is also a gantry crane. Okay, so why not it working? Why not it working? But the crane is same to this structure like this one, in which we also provided in bracing. So let us come back to the question and read the question. Okay, now in this question basically you see a W12/58 section is given with a yield stress of 50 psi and since supported and loaded with a uniformly distributed load. Okay, if the beam is laterally braced at ends only, this is important. Determine the flexure capacity if the length is 8 feet, 12 feet, 24 feet and 32 feet. And the CB value is fact, that is 1.14. Clear? And basically it is 1.14, I think so, because if your beam is subjected to a uniformly distributed load and the brace is only provided to the ends basically, so in that case basically your CB value is 1.14, I think so. Let us check it. Okay, here we have 1.14 because braces is only provided to the end point, so CB value is 1. If it is not given, you can choose this one from your manual. It also present in this manual AISC and also in LRFD manual. Okay, in this book you also find out the CB value as well. Okay, and here we have also basically in this book we have also the CB value. Okay, so both in books you can find these tables. Okay, now in this book, that is CBE book, there is also CB values, different CB values. Okay, you see here. Now let us start the question. Okay, here we have. Clear? Our given data is W12/58 section FY is 50 psi, beam is uniformly distributed, lateral base ends only. We have to find out phi b mn for 8 feet, 12 feet, 24 feet, 32 feet. Now, please watch lecture number 1 and 2, which is basically relevant to this question as well. In question number 1 and 2, so basically we calculate these values mn, these values for different cases. Question number 2 basically that is zone 2. Okay, so here you see your when you are increasing your length or span, you will enter from zone 1 to zone 2 and then lastly you will enter for this span, I think so, in zone 3. So let us start. We have a beam subjected to uniformly distributed load, braced at the end points. Clear? LV is 8 feet. Now LP is 300 RY divided by FY. This is from AIC manual. Okay, you calculate the LP, that is the limiting value which show you in which zone you are. Okay, if your LP is greater than LP, this means you are in zone 2. If it is less than this one, you are in zone 1. So LRFD manual, okay, or one can choose it from LRFD manual 14th edition, okay. 14th edition and LRFD manual, as I show you, you can, from this manual you can select that formula, you can choose that formula from this manual as well, and from this manual as well. If you examination, if this LRFD manual is allowed, you don't need to basically memorize things. You have just to select this formula. I will show you later that where this formula is. I think so that is in chapter number 3. Flexure design, okay, chapter. Beam design. In beam design chapter or flat girder design, you found this value, okay. Now, these values are also present in tables. I will also show you, okay. Now, for ice and C section, okay, and now 14th edition, LP is calculated, okay, it is converted into feet, okay, therefore that divided by 12. RY is 2.51, basically it is taken from the table, okay, from the manual. RY for section, we have a section of 1258, so you just need to go to LRFD manual and you need to choose the section, clear, W shapes, okay, and here you have to go 1258, okay, 1258 section, and let me want to show you this one. Here we have 1258 and here we have no RY value. Going to the next page, and here we have RY. This is RY, clear, and 58 you see here this one, this is 2.51, clear. So from that manual you select the value of 2.51, insert the value, divided by 12, you got this LP at 0.86. So you see 8 which is less than this LP, so you are in zone 1. From manual 3rd edition, from ZX table, LP, yes, as well from 3rd edition, that is this manual, okay, from this manual you can choose the value of LP directly, that is 8.86 feet. So let me show you where this value is, 8.86. If I don't use this equation, how can I choose this value directly from the manual? Okay, so now the value is basically in 14th edition as the manual. You see for W1258, you see the values are, let me show you here, LP, LR, okay, we need this value. In next step we calculate this LR value as well. So, and then we need this value. I will show you, okay, how to use this, okay. Now LP, we need LP value, and here you see W1258 has a LP value that is 8.87, okay, or 8.86. And similarly, if somebody uses LRFD manual, okay, here you see that basically section W1258 has a value of LP, you see, for 50 KSI, because we have this case, not this case. Remember, you have to point out that you will searching for FY 50 KSI. Remember, make sure. And here you see 1258 has a LP value is 8.9, I think so. Yes, 8.9. So we are close, okay. You can either calculate it or either you can select it from manual, okay, 8.9. And LR is basically 27, okay. You see here LR is basically 27 in this manual, and as well in this manual you see 8.87. Here the LR value is 29.8. It is an advanced version, so that's why it is modified, okay. 29.8, a little bit larger value, okay, but we use 27 from ZX table, okay. Now pi BMP is 324 kf feet, pi B 0.9, CB is equal to 1.0, okay, because remember we are in zone 1, so that's why we can't use 1.14. Remember, this is important point, okay. We can't use that value which we have here. We have to use this one, okay. Here we have to use this one, not that one. Clear? 1.14 because we are in zone 1. Why? Because LB is less than LP. Okay, LP, and this is the, you can say, this is the identification of zone 1. Zone 1. Clear? So we are in zone 1, so that's why we have to use 1.0, not 1.14. Clear? And you have to multiply from where this values comes out. Okay, you just need to multiply fy with your zx. Okay, you calculate the zx. How you can calculate the zx? Here we have zx. This is zx. Okay, and the value of zx you see here 86.4. So you need to multiply 86.4 with 50. Multiply that value with 0.9. You got your strength. And from this manual you can see phi b MP, you can directly choose 324. 324, from where this values come, this zx is multiplied with that fy value. That fy value, this 50, sorry, this 50 with 0.9, they got this 324. And similarly in next, if I show you here as well, for W1258 you see 324. Okay, that is your phi b MPX 324. So directly you can choose the value from manual, or either you can calculate it. Just find out zx from W1258, multiply that value with your fy, and then multiply by a factor 0.9. You got the value, that is 324. From manual 14th edition as well as from AIC LRFD manual as well, you can choose this value. Now going forward, and you see next, when your LP is 8.87, LR is this one, 5B MX 324. It is worth noting that LB is less than LP. I already explained this point. Okay, the beam lies in first category, and here we do not account for CB. So the flexure capacity of the W12 section is 324. We don't need to multiply CB because we are relying on zone 1. Now here your LB is increases, that is 12 feet. So due to increasing of LB, see the effect of LB, you just fall down from zone 1 to zone 2. This is the effect, and you already know that when the strength of zone 1 is the most largest one. If I draw the diagram, you have this one and then you fall. Now you see, here you are. Okay, now you are here in the first zone. In the first case, when your LB equals to 8 feet, okay, your LB is equals to 8 feet. So your strength here, the maximum one. Now when you choose LB equals to 12 feet, now your strength will be right here. Okay, there, and that will be okay. In the first case your MP, but here you see your value will be MR, that will be lesser than MP. Now let's see what will be the value of MR. So LB is greater than LP. Okay, the condition is clear, and you see, so the beam lies in second category. Clear? From 5B MP 324 feet, manual table 32, 5B MR 205 feet, because when you are in zone 2, you do not use basically that equation. You have to use this equation. In question number 2, lecture number 2, basically, I use this equation. So I don't want to waste my time on this equation. When you are in zone 2, basically, you have to use this equation, and you need these values. Okay, you need these values. You can either calculate these values, or either you can select basically directly these values from manual. Okay, I will show you these values from where these values comes out. Okay, in this manual, that is 14th edition, you see the values 5B MPX, clear, 5B MRX, and B, 5B. So all the values 5.69, okay, 205, 324, okay. If you have this manual, you see 5B MP, 5B MR, and BF, sorry, 4.96, 324, and here you have
basically here you have 234 basically. So there is a little bit difference between the two addition, okay, but this is not greater difference, okay. So they choose basically these values from 14th edition, okay, not from that LRFD manual third edition. So they just need to put these values into this equation, okay. Now you have this equation, you need to multiply all the factors, okay. They multiply 5e factors with all those, okay. Now you must note down that MP minus MR equals to PF, clear? And 5e MP LB minus LC, okay. MP minus MR divided by LR minus LP is basically equals to BF, okay. BF is nothing, okay. Remember, BF is nothing. It is basically, okay, your BF is nothing. It is basically equals to MP, okay, minus MR divided by LR minus LP, clear? So that's why we basically replace this value by this one, clear? By this one. So the question becomes easy for us now. You see here, I already note down this, okay. Just now you need to plug the values, okay, but remember, make sure you must satisfy this criteria that the strength which is coming out from these values should minimum are equals to this one, and I already explained this point in lecture number 4, sorry. Now you see, they just plug the values and they multiply 1.14. Why? Because we are zone 2, and in zone 2 we account for the CV effect, okay. So they just plug the value and they got 348.9, and this is interesting because it is greater than 324 in zone 1. So this is basically your MP value, that is your plastic moment. And in zone 2 and in zone 3 already I mentioned you that this value should never be greater than this one, clear? From the graph it is clear. So that's why we discard this value, okay, and we choose this one. So in this case, okay, that is for when your LV is basically 12 feet, your strength is basically 324, okay, you see here, 324, clear? This one. This is basically for second condition. Now we entering into the third condition, and in third condition your LV is basically 24 feet. Now if you change the LV value, now see, you are still in zone 2, okay, you are still in zone 2 because your 24 value is less than LR, okay. Where your LR, okay, you need to search it. Your LR value is basically, your LR value is where 27 feet. So once your value becomes more than 27, you will enter into the zone 3, okay. Now still we are in zone 2, so that's why we have to use the same calculation, okay. And you see here what is the effect. You see 324 is same here, LR, basically effect of LR, because in case 2 we have used 12 feet, here we using 24. So here the condition is okay, we have 272 feet, okay, and 324 feet, okay. Now 5 EMS is 272 feet, and that is the effect of increasing LV. You see, in first case, when your LV is basically 8 feet, you see the strength that is maximum 324. Now when your LV is jumping to the 12 feet, means increasing, you are still in okay position. That is mean that you can provide the bracing up to 12 feet, you still gain the same strength, that is 324. But if you increase if you double your unbraced length, that is 24 feet, you gain 272, almost you can say 324, almost 1/3, I think so, no, 1 1/3 something. Okay. Now in part 4, when your LB is 32 feet, you see the effect. Here you increase the LB length, and by increasing it, because you crossing your LR value, that is 27 feet, you entered into third category, and mean that now right you are in third zone. Clap. We have this kind. Okay. Now this is basically the distribution. This is zone 2. Clear? This is zone 1 and this is zone 3. So now right we are here. Okay. So that's why the strength is the lowest in this zone. Remember. So let us see the effect. Okay. That when our LB is 32 feet, what will be the strength in that category? Now here we need to calculate FCR, but remember, here we are in elastic region. Remember, that is in elastic region. Zone 2 is in elastic region, and when we are in elastic region, we have to multiply SX, not ZX. Remember this point. This point is very important. Okay, we have to use it right now. This one, not basically we have to use ZX. We can't use this because we are in elastic zone. Okay, we are in elastic zone. Now we need to calculate FCR, but remember this criteria should be satisfied. Your value should be lower than NP. Case 1. Now you see FCR is nothing. It is basically equals to this formula, and basically it is from AISC manual as well as from LRFD manual. Okay, I will show you inshallah this value as well. For example, I have notes. Okay, this one in CR basically they shortcut this formula, but your FCR value is basically in LRFD manual as well. Okay, so where I will show you inshallah this formula as well in my coming lecture. Okay, that from where this FCR values comes out. The derivation is very lengthy for this. Okay, but here they combine. Okay, and here they combine basically FCR with this value. Okay, NCR. So they don't tag this one. Okay, you see this one FCR. So just squaring it, you got the same one. Okay, I will show you as well in AISC manual as well. Okay, so but you have to memorize this equation, or either if you are using LRFD manual, you can choose this value as well. Okay, now or in this case NCR, you can directly use the same equation as I show you in slides. Clear? This one. Okay, now we have to use, okay, we can use either this one directly, we can calculate MN, or you can calculate FCR and then multiply with SX. You can choose the SX values for W1258 section from table or from manual. Okay, and multiply that value with FCR, you got the MN or MCR, or either you can use this equation. This MN can also be directly tagged from LRFD manual table 310 with CV is equal to 1.0. Now this value present basically in MCR value present in LRFD manual, but here where basically we have CV is equal to 1.0, not 1.14, and here the condition is that you have to use 1.14. So section 4113 of third edition, section 4113, chapter number 4, page number 113. Let us see this chapter number AC, chapter 4, page number 113. Clear? Let us see. Okay, one thing is very important to show you. These are the CV values. Okay, CV's values in manual. Okay, here we have 113 basically, page 113, 113, 84, 1111, and 112 here basically. From these tables you see here CV is equal to 1, and Fy is equal to 36. Now from these tables, how you can use these tables and you got the same value, I will show you this in later. Okay, let me finish the question. Okay, now you see if we used 14th edition of manual, psi b m in 188 feet, table 310 with Fy 50 psi and Cb is equal to 1.0. Okay, so table 310 basically in AISC manual, LRFD manual. Okay, this is table 50 psi, basically table 310 basically. So where the table is 35, this is not, I think so, this is table 36, table 36 continued. This is the same table they are. Okay, as they show in basically in third edition. From these tables they basically choose the value. Clear? Let me show you. I think so here we need interpolation as well because the values are not within the range. I think so. Let me show you where this value is. 310. Okay. So here we have basically LRFD manual. Okay. This is LRFD manual, and you see basically these differences are very important. Okay, you must remember these lines. Clear? Because these are important. Clear? Although in our case basically the Cb is not equals to 1. Okay, we have to use 1.14. So that's why let us check how we can use this table. Okay, so here you see the sections in these tables, and this is basically the reference which I given in my notes, chapter number 4. Clear? Now here you need to find out your required section, that is 1258. So search 1258. Okay, and here we have. Now you see we have 32 feet. This is an unbraced length and this is the strength. Okay, unbraced length versus the strength of the section. Where these graphs are. Clear? Now what we have to do, because you see our strength is basically how we can, you see, if we extend this 32 feet in this direction where the section line is there, so there are no chances to coincide these two lines. So for that purpose we have to extend the line in downward direction. So doing that, we extend the line in downward direction and we extend the same line in that direction. We see the line coincide at this point. I draw a line and you can say I extend the same graph here, and you see 188 kept feet. Okay, so 195 the same divisions, like here I make the same divisions and I got the value 188. So this is the way how we can use these graphs. Similarly, if someone using this 14th edition of AISC manual, so here you see the same table, here you see your required section, and here you have 32 feet. Now the span is basically 32 feet. Yeah. Now the complexity, or you can say the most hardest thing is here that the coincidence of these two lines is not possible within the phase limit. Okay, so that's why basically here it is very difficult for us to coincide these two lines, because we have to draw two lines. Clear? From 32 feet, clear, in this direction downward, and similarly we have to draw a line in this direction. So it's not coinciding basically within the range of the page. So that's why if you can do it and coincide this, it is a kind of interpolation. The point which you got from the intersection of these two lines, just extend that line here and you reach your required value of your n. Clear? Now let us see how we can calculate it basically by equations. Clear? Now these are the references. The value is 188. clear, from both tables, but for 1.0. Okay, let's see if we use third edition of manual by your 188, FY50 and this one. Doing a little bit interpolation of graph line, WFL and I already explained. Okay, if we want to use formulas, now what we need basically, we need LB, that is 32 converted into inches. We need E value, that is 29000 KSI. We need G value, that is 11200 KSI. We need J value, these are the Tarzan, okay, Tarzan properties of the section 2.10, and we need IY, that is 107. We need CW, okay, that is also taken from the table. J, E, J, and can be found in section 150 Tarzan properties. These J value, G value, CW values are 150. Our LRFD manual third edition. These values in 14 edition can be found in table 1.1. Clear? So let us see where these values are. Okay. So 150. Here we have 150. Let us see where these values are. 132. Okay. Here we have one. These are the Tarzan properties of the section. Clear? Each section has their own Tarzan properties. This is 147. You see, as W, that is warping constant. Okay. ECWGJ basically the whole thing. Okay. CWJ, and we have a section of 1258. Where this is? Where this is? This one. Now you see J value 2.10. You see CW value 3570 inch to power. This is warping constant. And where is your, what other values we need? J value is taken, G is nothing, I value is taken from sample table. Okay, CW is 3570. Clear? And similarly, if we use table 1.1 of this edition, table 1.1 basically going in backward direction. This is table 1.1, and we have to search basically 1235 section. Clear? Where is 1258? Here you see, look where is your required values are. Here you see IY value in 58107. Clear? And here your CW value is this one, and your J value is this one. Clear? So you see how we can choose these values. Now the thing is that you have to insert these values in that formula, clear, which I have mentioned you. You have E value, IY value, LB value, G value. This is constant, 11200. J value, E, CW, all values are in right in your hand. Just plug the values, okay, and make sure you use right click calculator, and you got your value 209. Multiply it with CV, that is 188. Now here you see CV is equal to 1.0. You got this one. If you multiply it with 1.14, you got your required value, that is 214. Now see the difference. You got your value 214 in case 3. Now see the effect. You fall down from a 324 to 214 value. Okay, this is almost, you can say, half of that capacity. So this is the difference. This is how basically LB matter. Okay, this is how basically when you are increasing or decreasing your LB value, basically it make changes. Okay, in this video you also see that they basically provide, although in lateral, okay, lateral as well as they are providing inclined bracing as well. And you see next what they did basically, they provide further, okay, see, they provide further lateral bracing. Why they are providing? To decrease their LB value. That makes these girders more strong. Okay, you see, here we have, you see, the whole length is divided into smaller lengths. Clear? the whole length which started from that point to this point, and they divide it into small portions like this one, like this one. Why they basically did it? Why they provide these lateral bracing? To count for the effect of LB and to use the CB value. Okay, now basically this is wrong, because once you are decreasing your LB values, you are jumping from your zone 3 to zone 1 basically, and when you are jumping to zone 1, you got your maximum movement value, that is MP. So that is the basic effect of LB basically, and you show mathematically that how it differs, that how you jump basically from a capacity of 214, I think so, to 325. Okay, so that is the effect of LB. And next, inshallah, we do the rest of the question, that is question number 4, which is related with the composite section. So we did inshallah this example as well. Up to this point, you have any question, any suggestions, please share with me on my YouTube channel, Misbahullah Engineer. Thank you for watching. See you in the next lecture. Thank you.